When you're trying to resolve forces, you need to take into consideration gravity. The whole point of resolving forces is to take a diagram, put as many forces as you can, and then find out the resultant force. We know the resultant force from F equals ma, or force is equal to mass times acceleration, seen by there. Now here, the first force that we can put down is gravity. Gravity always acts down, meaning you can take your object and you can put a force that goes straight down from the weight. Assuming this weighs 10 kg, you can say that this is 10g, because force is mass times acceleration. 10 is the mass, acceleration is g. However, all objects have a reactant force, meaning it must oppose the force of gravity. Otherwise, this object will keep going down and push down and eventually until you get to the center of the earth, which is wrong. A reactant force acts perpendicular to the plane it is sitting on, or basically on the floor of the that it's sitting on. Since it's sitting on this floor right here, resultant force will act up perpendicular to this. So resultant force will be from here. To calculate resultant force, you need to first of all figure out what the opposing force in this direction is. Now, if I was to connect this up, this is actually a triangle, and this triangle here would be congruent to this, or similar actually, meaning this angle will always be the same as this slope. Now, we can use standard trigonometry and basically say 10g cos theta is equal to the force going in this direction. Therefore, the resultant force is equal to 10g cos theta, or cos 30, because it's acting in the opposite direction. Assuming that you have all of these forces, you've just solved these forces. Now, gravity, or in general, all forces have a positive direction. They are all positive. But all of these forces, their direction can be positive or negative depending on what you take as your positive and negative. And then thirdly, all these forces, they have a vertical component and a horizontal. So this force of gravity down here, it does have a component that's going down this way. And we can actually draw this force as the force that causes the slope to go down. For example, if you had an actual slope and you put an object on the actual slope, it's going to go down the slope. And so we need to understand what that force is. And that force is actually a subset of gravity. And if I connect these together, then this angle here is 60, because I've just made a right angle triangle between here. And as you can see, it is 90 minus this, and that gives you a right angle triangle. The other way you can do, of course, is using sine, because technically that's also this angle here, the same, which is the same as there. This force here is equal to 10g cos 60. Cos 10g going down, and you find out that this force and this force, when you combine them, you get 10g in the middle. So now we got the force that brings the object down, the force that stops the object from going straight down into the ground, and then gravity as well. This is successfully resolved. Let's say I had acceleration in a different orientation. Let's say acceleration, the block was going up. This means there must be a force here. There must be some sort of force going there, and you can use that to find the actual force by using F equals ma, or the resultant force or total force will be equal to this mass times acceleration, and then you just use standard algebra. But as far as resolving forces go, this is ample, right? I hope you enjoyed.